To be
This
clear
is not
here,
the main point.
the math checks out. It's
She
fine.
doesn't,
You were
she
trying
doesn't
to
know
get
where
him
the
on a
formulas
gotcha
come
point,
from.
which he answered.
He said I
and
drew
now
the
we're
triangle wrong
we're
to begin
having
with.
a rigmarole
Then he
on something
searched
that
around
doesn't
for
matter.
something. He didn't come up with anything. He couldn't answer me. And then eventually said H is negligible due to a sine approximation. That's a small angle approximation.
No, that's on the other side.
This is what
It's
you use when you
negligible.
derive the period of a pendulum chain. Hang on, I'm not done. So this has nothing to do with this. I'm just illustrating that you don't know the words you're saying. And you're following what somebody else derived incorrectly.
So did you have an actual contention with the math, though? Are you going to get to that point, or are you going to keep
Yes,
reiterating the other thing? Because if you don't have it, an actual point, then we're going to move on.
Yeah, well, I know you want to get rid of me, but this has nothing to do with the triangle that's drawn that Shane was showing me. Wherever it is, I'm scrolling through.
No, it does, because we're equating it to the other side.
I got you, dog. So it does specifically, and he showed you that, and your contention with the math was to try and get a gotcha, man. Thanks for coming.
No, it was to show that he doesn't know where the math.
Yeah.
Son, thanks, bro.
All right, cool. Globe guy McGloberson, you still here? It's your turn or whatever.
It's my turn or whatever.
What's up?
That wasn't a McGlobeface.
That wasn't a very good intro.
Yeah, my bad. What's up, man? How are you?
Sorry, bro.
It's good. It's all right. Doing good. Just enjoying that conversation.
Any proof of globe religion?
It would have been nice to get to the point sooner and then not go for like a point that's not irrelevant. And then when asked for the actual point of contention, there was just a reiteration of the gotcha. So like that was like kind of, like not very satisfactory for me personally.
That's fine. I mean, Shane didn't know how it got to that point. I mean, I was listening the whole time. So I think that was his point.
How would the other guy have done the math? Like, what would his numbers have been? That's kind of what I was
The exact same conclusion. That's why I was confused.
I think his point is you're taking other people's math and doing it that like
he didn't claim
necessarily knowing it yourself.
Deriving Pythagorean theorem to get the distance to the horizon is nobody's specific math, right? Everybody can do that.
Well, I mean, apparently not, though, right? I mean, wouldn't you have known what he asked for? Look, it's a moot point.
Well, he asked a really stupid question, and it took me a while to realize what he was asking.
It wasn't a stupid question. He asked you what goes on with this h squared there. It wasn't a stupid question. If you knew how to derive it, you would have known what happened to the h, right?
Yeah, but it wasn't the answer or his answer, so I was confused.
Okay. You have the right to be confused, but I think that does point out that you don't necessarily know the derivation yourself that you claim to have done, right?
Well, no, it means that he's asking a retarded. I mean, it's a silly question.
The questions were confusing that he was asking. He was asking.
He asked where'd the h squared go. It wasn't confusing.
Well, there's an equivalent thing would be like, hey, how come this pre-simplification step, three steps before here, how come this drops out? And the answer is the same every step because it cancels out or becomes equitable, right? So to point out one of those is kind of silly to me, and I couldn't really grasp that was his main point because he took 10 minutes to get there as he quietly researched it and had to go Google it to figure it out and compared it to the website before he was like, aha, I figured it out. I got the same answer. So I was just confused.
All right, that's fair enough. I think to have certain conversations, it's okay to try to baseline the knowledge of the other person before you continue.
Dude, sitting there and asking gotcha questions is no way to actually have a conversation. If there's an issue with the actual information, that's one thing. But if you're just going to sit there and pester somebody, I mean, we could do the same thing to you, and I guarantee you would not be able to answer every single question. And plus putting somebody under pressure is not a good way to try to test their knowledge by like pressuring.
No, it is. That's probably the best way to do it.
Interrogation is one of the worst ways to retrieve knowledge from people.
It's not interrogation.
And studies have shown that you cannot accurately and actively retrieve knowledge to your best ability whenever you're being interrogated, bro. Seriously.
How is it interrogation when you're having a debate about a scientific topic and you question somebody's knowledge on that topic? How is that interrogation?
He's sitting there questioning Shane. He didn't he's just pestering him and constantly questioning him.
He had the same conclusion, and he made an argument about it. It was weird.
But that's so crazy, dude.
Yeah, and he had to go Google stuff. I mean, he showed what he was Googling. So he tried to come back with a gotcha question.
Do you know everything? I mean,
no,
I'm guessing you guys use Google a lot.
No, hell no. No, I don't know anything.
When the point was made, it was clearly not a logical point. But the conclusion was the same. That's why it was very odd.
I don't know if you were there at the start, Globey, but he was like, "Is this yours?" And I was like, specifically, no, but people have attributed it to me erroneously, right? It's from Life is Short, and it says Angular Resolution Video, and then somebody also wrote up a Word document that got attributed to me somehow that also I didn't write. So definitely not mine, but yeah, we have used it.
The Rayleigh's Criterion document?
Most of the visuals, dude. He did a 3.5-hour video on Angular Resolution from which most of this came. And I say that all the time. So no, it's not mine. No.
But okay, great. But like, we didn't look at that and look at it with a critical eye is the problem.
Who's we?
You guys. You posted it on your webpage, right?
Yeah, well, I've watched it many times, dude. I've used it. I've extracted all the images. I've, put it through other stuff. I've used it in many presentations. Yeah.
Okay. So, then the problem is you haven't critically analyzed it because there was a lot of shady things going on in that document, which I'd be happy to point out for you right now. Because this is honestly the crux of your guys' entire argument over the, however long, is we see the same shape that the Earth is, that the globe contorts to be or proposes to be because our eyes just see that way. And it's based on the Rayleigh's Criterion. And that's where it all starts, right there. Right? But if that's false, if that's broken, if that's incorrect, then your whole basis of everything else is incorrect.
Yo, I've got a video of that guy right there talking, changing the horizon from a physical geometric horizon at one point.
Yeah, Alan, this is what this guy does.
I'm in the middle of talking, bro.
You're just gaslighting is what you're doing.
I'm not. I have
if you want to talk about that, you dress up as a chicken and measure and fold toilet paper to the moon. We could do that too, Nathan.
Get muted by someone?
Yeah, hold on, lads. Hold on. It's not talking over.
Nathan's just a gaslighter, Alan. That's all he does.
Asking Shane a question. If you go on to start talking about Globey or whatever without saying anything relevant to what he said, then it's just disruptive and not adding anything.
Oh, sorry, Alan. I didn't know.
You're good.
He didn't know. Yeah, that's all he does on TikTok is he steamrolls every flat earther's lives.
I'm hanging out with Free. I didn't hear what you were crying about at the moment. Go ahead, ask your stupid question.
Yeah, okay. Yeah, you'll find out soon enough. He rolls in.
Wanted to go over the Rayleigh's Criterion math.
Yeah, I was. I can show my screen if you make me big. That'd be helpful.
Sure.
All right, so what do we got? So we got the Rayleigh's Criterion, right? So we're going to use this formula. This is what you're using. Now, this guy, whoever you took this from, this is your website here. He comes up with some interesting numbers. Very interesting numbers. So first off, he doesn't calculate for theta. He doesn't calculate for theta. I know he has a number here of 0.0216. He doesn't calculate for that. He backs his way into it. And we know that because the angular resolution of the human eye is 0.02 degrees. It's one arc. It's on 1 arc minute, right? It's 0.02 degrees or 0.0003 radians. So it's 0.02 degrees. But what did he use in his formula for that? He used 0.02176062. That's 8 significant figures. Now, why did he use a number with 8 significant figures? And where did he get that from? First question. That's the angular resolution of the eye that you guys put into the formula for the Rayleigh's Criterion.
You're asking why it's 0.02 or whatever?
Why is it 8 significant figures? And why is it so specific? Where did it come from? He never says where it comes from. He just pulls it out of thin air. Why didn't you use 0.02 as the science says it is? It's a very specific number, isn't it?
Science doesn't say anything. Science doesn't have a mouth, vocal cords, doesn't speak English or Russian. It's just a method of determining cause and effect. So
awesome. So where'd this number come from?
Let's say it's wrong. Go back with 0.02. Come out.
Okay, so well, this is the point though. So yeah, so it's a very cherry-picked number, 8 significant digits, Because what he actually did is he started with needing to get to this number.
Let's say it's wrong. What's the right one?
We are. Here you go. 0.02 is the right number.
That's what he used.
Wow, this guy. You're really peak scientific mind there, Nathan. No, he used 0.02170062. And if you don't see a problem with using that to back into your number, then I don't know what to tell you. Because he took...
I mean, it is weird. It's interesting, but let's assume it's wrong. Let's take that.
Because this is what he did. He needed this number.
Right. Let's compare the two and see if there's what the difference is. Like, where's the issue here?
Because he needed this number. What he did was he needed to solve for this triangle to get the 3 miles to get the radius of Earth to match. He needed half of this angle. So he took half of this angle and said, I need that half. How do I get that half? Well, I'll put the half here and I'll just cherry pick 666 nanometers of the wavelength of light. I'll just pick red for no apparent reason other than I'm going to claim it's because it's minimal refraction. Okay, whatever. Cherry picks that number exactly. And then he cherry picks, he calculates the D out of this. So he started with his answer, he put that in, and then he's calculated for D, which is the diameter of your eye. And he got 2.155, another oddly specific number for a diameter of eye. So he calculated out exactly what he wanted by backing his way into it using his conclusion. He needed this to get to the radius of the Earth. And showing you that he's cherry picking all this is whatever. This doesn't even mean anything. Like, just because this angle, it matches that angle of the Rayleigh criterion and you can get R out of it, means nothing.
I really wish I knew you were talking about.
This argument means nothing. It doesn't prove anything, and
What it proves, Nathan, is that the math.
I was still in the middle of talking, bro.
You're just gaslighting again.
No, I'm not.
Yeah, go ahead. Continue your gaslighting.
Proving globe religion, but cool story, bro.
I'd like to ask you a question in a minute. I'll wait though.
So yeah, if you do the math but use the average wavelength of light and then the average pupil diameter.
Can you go back to the image real quick of where he had that 8-figure number real quick? So
yeah, and then just do all the same math. You end up with 13,000 as your radius. It's meaningless.
Well, no. Right, so 0.021 and the trailing after that doesn't really matter. You can use 55726, you can use 706 through there. The third decimal place doesn't change it that much. Is that your argument, dude? First of all, and like
No.
even if you do it out, right, and even if you remove the cherry pick 666 wavelength of light and you remove the diameter of the people, you can still solve for that, getting just the angular resolution limit, right? You can still solve for 1 arc minute or 0.21 degrees by just the distance to the horizon and the radius from the other way. So that's why D equals the tangent, D equals D over the tangent of theta would still work with that. Not to mention that you can derive it using other optics, and you can use like bigger telescopes with different wavelength combination. There are literally infinite tuples of wavelength and diameter that would satisfy it, and just as many that wouldn't. And
No,
the
there
ones, and of course there are, and the ones that wouldn't, you can use to like falsify it would just mean that the geometric horizon would have to be larger. Namely, like for say the black swan observation, if it's longer than the geometric horizon at 1.22 times the square root of the observer's height in feet, then of course the refraction would increase the radius so that it would make it observable, right? That's how that would work.
So you said a few things wrong there. He didn't solve for the 0.021. I just told you that. And you saw that in your own math. He started with that.
Wait. Sorry, can you go back to that real quick? I was trying to read the full sentence. It gets cut off because it looked like it said where he derived it. No, on the other page.
I don't know what other page.
It was the one you had up before that had like the image.
The picture?
Yeah. Because it looked like it said where it was about to be derived from. It said it was about.
I don't think I showed the picture.
Yeah, it said it inverted the height or something like that.
I don't know what you're talking about.
Yeah, it was the first one you were showing when you were like, right here is the 8-figure number.
Yeah, that was this, the 8-figure number. It was words. It wasn't a figure.
No, hold on, but now this is a different page though. Oh wait.
It's not. Is that what you're talking about?
No, go up a little bit. All right, right there. Go to, turn. This was inverted as the height information, turn a little bit. Information loss across the same angle. So here, the red horizon gain for the 6-foot observer across is 0.
He says it in the first sentence. That's what you're looking for. The angular resolution limit of the human eye is approximately between 0.02 and 0.03. And then he just says the angle at 0.02176062 degrees and an assumed light wavelength of 666 was used to derive the radius of Earth. So he just cherry picked a number between 0.02 and 0.03.
Oh, gotcha. Okay.
And not only just cherry picked a number, it's too specific to be cherry picked. So he backed his way into it. He calculated that number out because that's the number he needed.
Well, it works out when you do, 1.22 times the 666 over 1.22. It's like 0.0216 in degrees, right?
You're not. I don't think you're getting the point. Okay.
No,
He's cherry picking numbers to get to a conclusion.
Right, but did you hear how Shane was saying you could use different numbers and get the same thing? So it's not necessarily cherry picking, especially when it's based off of the average wavelength.
It's not the average. It's 666. He randomly picked a red wavelength number, 666. It's not the average.
Isn't the average?
This is 666 right here.
500 and 600?
Yeah.
No.
The average is like 450 or something. 550.
We didn't pick the middle. We picked red orange for the most resistant to refraction at the observer. That was the reasoning that he put.
Okay. Do we see in just red, or would it be more honest to take an average? Because we see the entire wavelength of light. We don't see just 666, right?
Well, you wouldn't see one wavelength anyway. So what wavelength would you pick to simulate all of them at once, do you think? This actually just simulates a snapshot in time, right? All these
You would
things,
pick 500.
all these circumstances change by the second, right? The atmospheric opacity, things change, the humidity changes, the temperature changes. So what we're emulating with the math is a snapshot in an instant. So at best, it was an approximation, right? So when we use 666 or red or orange, you can easily do other combinations, right? That will lead to a different radius, but you can also do different ones that'll lead to the same radius. You can do optics for like thermal, for high imaging telescopes. You can do nano. You can do, some of the higher optic telescopes have the same angular resolution limit with different wavelength and diameter. That's what Raylaigh's criterion is mostly used for, right? It's high degree optics. Sorry, dude.
Yeah, that's kind of the point, though. You can put other things in and get other answers and other radius values, right? It's meaningless. You just found the right combination to get you the number you wanted to show everybody and go, look, I came up with the radius of Earth. That's great. Great. It's great. You found the one combination that works, or a combination that works to get you the radius.
This argument is meaningless and going nowhere. Is this the best the Glober's got in 2025, guys?
Well, it started.
Nathan, when you want to contribute, let us know.
Yeah, it started off fairly strong, but there's other ways you can derive it, so it's not really. Okay.
So then part two, we assume everything's right, and it's not, but assume everything's right. How does getting this angle, the 0.0216, and calculating R out of that, how does that equate to we can only see to that radius, 3969? That's the limit of our vision. How does that equate to that?
What do you mean?
So you use Rayleigh's criterion to solve for this angle. You got 2.0216 degrees. How does that mean? How does putting this number into this equation and solving for the radius of Earth mean that's the limit of our vision?
With this triangle right here, let's see. Right?
Yeah. Because that's measuring from the center of Earth. I don't even get that.
Well, that's using an arc segment for a circle of approximation, right? So you use the same distance to the horizon over there when you get the same approximation of the radius of your vision, right? So
okay, great. But how does that mean that's the limit of our vision?
What do you mean? This is what we're mathematically deriving from the formula over here.
You just solved the triangle. You said that I have an angle and I have a distance along the surface of 3 miles. And so you solved for the R. How does that tell us that's the limit of our vision? Because that's your claim. All you did was solve a triangle.
Well, yeah, and then we use that triangle to approximate your limit, right? On a flat plane, seeing in spherical limit around you.
I mean, those certainly are words, Shane, but I don't, doesn't answer the question.
The comparison, right, is distance to the horizon on a sphere of a specific rate of curvature and distance to the horizon on a flat plane using the angular resolution limit of the human eye. That's the comparison. So when you can use r equals d over the tangent of theta with that theta being, again, 0.021 degrees, then that's what gives you 3959 as the main radius of the limit of your vision.
That gives you the radius of Earth. That doesn't give you anything, has anything to do with the radius of your vision.
Well, you can say that, right?
It's in your own picture. I mean, it's in your own picture. I can say it, but it's in your own picture.
It's a circle with an arc segment. That doesn't have to be the Earth. That's what we're saying. Like, what it would represent, how far you could see, there would be an equivalence there based on the calculation just using triangles.
Right.
So this circle's your eyeball?
Well, you're getting a circumference, right? That's what we're measuring. That's what we're deducing of a circle. And you're saying that circle of a circumference is the Earth beneath your feet. We're saying, well, no, that's the limit of the whatever you're seeing, say each and every side, all over you.
I'm sorry, say that again. I missed that.
It's just the application of the circle, right? You're saying that that's the circle is the circumference of physical Earth beneath your feet. But we're saying that's the circumference of the limit of your celestial vision. That's how far you can see. Right, that's how far.
But you understand you're just saying that, right? You haven't equated this picture to your eyesight.
What do you mean? We went through the whole first,
the resolvability limit.
Oh my god.
Guys, you got an angle of resolution from the Rayleigh Criterion, which tells you what? What does that tell you? What is that theta telling you? Like, what you solve for theta? What is that theta? What is it?
It's how far something can be apart before
Anybody?
it's resolvable.
Great. Great. So that's talking about the angle between the two objects. Right?
Mm-hmm. Which has a limit.
Sure.
And we're deriving the limit to the horizon off of the same functionality.
Now you're essentially saying if I was standing here with that same limit of vision, the 0.0216 degrees, that the limit would be 3 miles?
No, we're using the arc segment, right? So we're using the circle.
The arc segment,
like,
3 miles.
Like so if you look over to the right there, right, where the circle is and how there's a dude on the top, right?
Yeah,
and that dude's looking over, right?
That is that. That is that.
Yep.
Same thing.
Exactly, right? So that's a circle.
Right. So your dude up here is looking this way.
Yep.
It's not over here looking this way. Right? This is the angle of the limit of vision right here. That's the 0.0216 times 2 theta. What does this angle have to do with him over here looking over here?
That helps compute the distance to which things become unresolvable and thus compute the distance to the observable horizon, or in this case, the visual limit where the sky meets the ground, right? That's why it's comparable to the geometric horizon. That's what.
But it doesn't make things curve. It's just telling you that the angle between two objects before they're unresolvable. You solved for something and then just said, I'm going to use that thing and say it means something else.
No, we're using the angular resolution limit to determine the distance to the horizon, right? And we noticed the similarity with the geometric distance to the horizon using Pythagorean theorem from the last dude, right? Went all through that. That's the geometric comparison to this optical limit. We're using the distance to the horizon as the main factor. And then we're using the angular resolution limit in that r equals d over the tangent of theta formula.
Those
to
aren't
get the
equivalent.
radius of the circle.
You can't just say they're equivalent. Those aren't equivalent. What you do with the Rayleigh's criterion is when you solve for theta, you get your maximum angular resolution. And then you can solve for a distance using that theta. You can give a distance and then solve for how the maximum distance an observer would have to be to see that. So you can take the 0.0216, put it in here, put like 10 miles in here, and then you can say, all right, given that 10 miles based on my angular resolution of my eye, I would only be able to resolve two objects if they were you know, 6 feet apart from each other. If they're any closer than that, they'll look like one object to me, or at least they'll start blending together. That's what this is doing. That's what you use theta for. You don't randomly plug it into an arc length of a circle and claim that means something about the limit of your vision, especially using cherry-picked numbers as we went over in the first place. Because again, you can change this value to anything, like you said, and then you can change, you know, observer height and all that, and the wavelength of light, and get a million different answers. Why are those not valid?
They're all valid, dude. You can choose infinite tuples. You can use Rayleigh's criterion to apply to anything you want. You can use it in telescopes. You can arbitrarily start doing dumb shit with it too.
All right, so I used the average wavelength of light and the average diameter of your pupil, and I got 12,500 miles as the radius. So how does that equate to what you're doing here?
We've kind of been down this road before,
over and over and over and over again.
So yeah, if we could do like a final thoughts or whatever globe, and then or Shane's already kind of reiterated, so if you just want to like end on this, like get your final thought out so we can move on to some other guests or whatever. We've been trigging hella hard and Shane's got to go to work tomorrow.
That's fine. I guess final thoughts is stop saying that our vision is limited by the Rayleigh's criterion. It has nothing to do with the subject you're using it for. The numbers were cherry picked, as I already proved to you. These numbers were backed into to get you the answer he wanted you to see. And you should look through this with a little bit more of a critical eye. And I guess that's it. I mean,
I missed the beginning of it, but was that an argument about globe people disagreeing about the radius? Like,
no. Oh, maybe before I was here.
Well, Kobe, regardless, dude, you've been respectful, and I thank you for being chill, because honestly, our experience has not been terrific. You're probably the most respectful Glober so far. So yeah, welcome to come back anytime.
Absolutely.
When has our interaction not been good?
No, we're not saying you. We're saying just like with other people. We're saying you've always been mad cordial, so we're just saying respect.
Right. I'm a match energy guy, so when someone like Nathan comes in here, I'll fucking match his energy because he's.
Yep.
I'll reserve.
No worries, lad.
I'll reserve comment. I guess I'll end on before I get out of here. You know, I'm sure your guys are close with Nathan, or I don't know if you are or not, but he will destroy your live here on TikTok. Take my word for it or don't, but he will absolutely come in here, steamroll your live, kick every Glober out. If you mod him, I don't know if he's a mod here or not, but he will kick every Glober out and mute them repeatedly, and he'll ruin your entire live. So.
He's not here. Hey, Globy.
That's fine. He knows what he does, and everyone else knows what he does.
Well, that's all good. He's not here though, so like, let's not talk about him. But I appreciate the concern though. But yeah, what's up, JT?
I was gonna ask Globy if he didn't have to run off a couple questions or give like my feedback or context on this whole thing.
I mean, I don't have to run off. He sounded like he was done with me.
Okay, my name's JT. I go by Run Boston Bear. I'm just a chill dude. So the energy I bring is not attacking in any way. What I see Shane having done here is backwards derive or undo the deception. If the globe is a deception, I know that's triggering for people that are like globers, but if we really do have a limit to our vision, and we do live on a stationary topographical plane Earth, and the stars are apparent, like if the sun and the moon and the stars are in apparent locations to each observer, then he's basically like, I figured out with math how they came up with the globe belief. And I'm not saying it's a religion or it's a trick. They may have believed it to be absolutely true because they saw boats going over the horizons, etc. So that's what I think Shane is getting down to is.
Okay, I mean, I can address that. So here. So it might be best addressed in this picture, which Allan put up the other day. So it doesn't even make sense when you're talking distances, right? If you're going to claim this is the vision, the limits of our vision, right? That goes all the way around. It's an arc, right? So if this is the radius of Earth, I guess I should show you this one. This is the radius of Earth. Then that's the radius of Earth, or the same radius anyway, right? But now you're saying the limit would be out here, not at the 3 mile horizon.
That's a very poor construction visually for sure. That's thrown together in Canva.
Well, isn't it
Okay, but I mean, this is how you're representing how to find the GP of a star, right?
Yeah.
And I will point out that, Alan, I mean, I did point out that you got this math wrong the other day, and it seems you fixed it. So I don't know if you wanted to discuss that, but you did use 60 here as your hypotenuse, 60 degrees, 60 degrees. And when I pointed that out in your comments, you kind of told me I was wrong. Kind of made me feel stupid. I got upset. But it looks like you fixed it. Over here, you put 39.59 and 39.59.
Yeah, that's probably not bad too, man.
Yeah, so that was Shane's bad, but it is fixed now.
Oh, we can blame Shane.
I appreciate you pointing it out.
You pulled it from my Glowbusters thing, which I had it
Shane
wrong
also
with.
told me I was wrong.
Well, no, because if you use 39.59, you can always deduce like that. You can approximate that adjacent, right? You can just get, even if you use just the unit circle, right, which is why I use 60 degrees. So if you use cosine of 60 degrees, it always yields 1/2. So that's why you get 1/2 times 39.59 would be that, right? And you can also get other ways using right angle and alt angle approximation.
Right,
but
I mean, you made the mistake of distance to star being 60 degrees. That was a little boo-boo.
No, yeah, I put it there because I was trying to illustrate it, and it took it as the hypotenuse. So that's my bad.
A little boo-boo, but the point is, it still holds. If you're claiming this is the limit of our vision, why is the limit of our vision start at 3 miles, not 39.59?
You're observing different planes.
What do you mean 3 miles?
Well, that's when things start to quote unquote go over the horizon, right?
Well, we're not talking about ground-based observations. This is like to the celestial heavens. Yeah, we're talking about stars. We're talking about the distance to the stars that we use in our equidistant web around us.
But this is also a reason you guys use for things going over the horizon, right?
Well, we related it with the math, right? This is the other application.
Right. So if you're going to use this as a reason why things start to disappear as they go over the horizon or get too far away, then that has to equate to that, right? And this is telling me that the limit is 39.59, which is, that math is contrived anyway, but how does it equate to 3 miles? How does that relate to the 3 miles, not 39.59, when things start to disappear? Like, oh, shit.
Well, again, we're using distance to the horizon for the surface level observations for a 6-foot observer. And then we're deriving the radius of that circle with which we're using an arc of it, right? And then we're reapplying that circle to a radius of our vision. So in this depiction, we're using the circle to depict our hemispherical vision. And that's why we have the equidistant web of 39.59 in this specific visual.
Okay. Not really sure what you said, but okay.
No, Shane, will you please repeat that? Because I did understand what you said, and that was very important. So can you please repeat that for everyone to hear again?
So, yeah, 3 miles is the distance to the horizon for a 6-foot observer, right? Mm-hmm. But we use the R equals D over the tangent of theta to get the 39.59 for the equivalent. And that, so of course, we use the circle to get that. We use an arc segment of a circle to get that. And then we're applying that circle differently. You apply it to the ground beneath your feet. We applied it to the radius of our vision. In this case, it's depicted visually as a hemisphere around the observer. So that's why the 39.59 is the distance to the star.
Yeah, I mean, you just kind of went over exactly how you calculated the 39.59. But I'm still not sure how that applies to an observer watching a boat go out into the distance. Why is the limit not at 39.59? Why is it start at 3 miles?
Ground, you'll be able to see, like, I don't know, an ant or something like that. And then
the
when
angle between the ground and the horizon is smaller than the ground and the sky. So you can you see like, over like if you were at the equator, you would see Polaris at your horizon. So like that's that's pure sky observation there. So like the difference is you're talking about the sky versus, just like a horizontal observation. So like this is why they relates to a hemisphere and why they have it set at an equidistant web. That's what I was talking about earlier when we were talking about the celestial sphere and the position of stars and how this relates to the latitude longitude system, because this is all equivalent, and this is all how it works. So
I mean, I get what you're saying. It's equivalent. I mean, just saying it's equivalent, and I showed you why it's not equivalent earlier.
With respect, Shane also showed you how it's not cherry picked and it is equivalent.
Wait. He showed me it's not cherry picked. Can you show me that again? I missed that part.
Yeah, he gave several examples of different optics you can use for telescopes and stuff. There's actually an entire spreadsheet. Shane, if you could link that to me, I'll just send it to Globe or whatever. But
Yeah.
there is other things you can use, right? So
Yeah, if you put in different wavelengths and back your way into the number again, you could sure get different numbers. So I'm not sure how that disproves that he's cherry picking.
Well, you say back. Well, hold on a second. You say back your way into it, but if we're changing the wavelengths and diameters, then and we're calculating it, and it comes out to be the same or similar, then we're not backing into it. We're just calculating it with different variables, like what you're doing. So we're saying like this, and keep in mind this argument purely is optical. So like, you know, even though you might not acknowledge our position, the equivalence here, we would have to move to a different thing to argue how to determine which interpretation is actually correct, because we're kind of just, you know, kind of reifying each other, or, you know, each other's positions essentially.
I mean, that's the argument you guys want to make now, is that we're reifying each other's arguments. That's new. That's what you guys are trying to do now, is say that it doesn't matter, there's an equivalence.
So we derive the radius, which can't be proven empirically, of the ground curving with our eyesight, and the convergence rate. This is the direct correlation between convergence rate that we're talking about, right? So it's a fundamental like law and perspective that there's foreground, midground, and background, and the midground would be up until the vanishing point. The background, everything, the stars, the mountains way off in the distance, that's all in the background. Right?
Great.
That's why we have a visual to the horizon at 3 miles, or just under 3 miles, with a 6-foot observer, but well beyond that in the background. This is depth perception 101.
Depth perception 101. Okay.
Yeah.
And that limit of vision is created by backing your way into the limit of our vision. Because if you use the angular resolution of your eye and you use the average wavelength of light, you can calculate like 3 miles is about 6 feet of angle between objects. So as long as they're further than 6 feet apart, you'll be able to see two objects, right? If they're if the boat's at the horizon, the boat's at 3 miles, you wouldn't be able to distinguish them between each other because the boat's, you know, touching the water.
It's matching the convergence rate. Absolutely.
Yeah, but it's not. So the drop is, how much is the drop over 3 miles?
If you have a 6-foot boat,
67 feet, right?
It should match. And if you
doesn't,
it matches your convergence rate. If you have a 12-foot boat,
67 feet of drop, right?
But
that's what the globe math says. That's how we see boats go over the horizon, not matching. You only have six feet of angle between the two using Rayleigh's criterion.
Well, actually, at that distance, we'd have 3 foot and 3 foot with a bulge in the middle.
But then why when we zoom in, can we bring them back in though? Like, it's clearly an optical.
Allan, that's never been done.
You've never seen someone zoom in and bring a boat back in, bro, when it goes out?
I've seen someone zoom in and bring a boat that can't be seen back in. It's too small to resolve by the eye or the camera. A small boat. You've never, ever, once ever brought a ship that's hidden by the horizon back into view. Ever.
Well, you would never know
This
if
is the
it's...
big boat argument.
Dude. No.
I didn't bring it up. He brought it up. If someone can show me one, I'd love to see it, because all you're going to show me is a small boat that's very small, that can't be resolved by the camera, suddenly appearing as you zoom in. You're not showing me a boat coming back from over the horizon, ever. I can't believe you guys still talk about this like that's a thing.
Because boats
Hey,
don't
guys.
go over the horizon.
Well, I know you claim that. I know you claim that, right?
Big boats don't.
Respectfully,
That's why it's very
respectfully,
laughable to us.
I came
Part
on
of-
the live, and you guys been talking about this for a while. A whole bunch of apparent stuff happening. You guys step out to the house and see this stuff. Let's talk about 3-4 vectors on a spinning top. How about that? I know Space Audits has something to say. I think I saw in Witsit's, I think the core of the belief, that's when you added a little bit onto there. But it was the wobble in Schooling Globers and Witsit's
The four
program
quad
there.
wobbles.
Yeah, I mean, come on, guys. Let's stop arguing these little things and let's talk about the four wobbles. That cannot happen, guys. Come on now.
Dude,
All
the
right.
Chandler wobble, obliquity of the ecliptic, nutation, and what's the other one? I forget it.
Yeah,
The
what is the
general,
other
Hey,
one?
just a general wobble.
Can someone show me a ship being brought back from over the horizon? I want to see one. I mean, maybe if someone can go find one while other people are
Yeah.
No,
talking.
man, that's math, but this is like gyro, what's it called? But yeah, you can't do four wobbles. You want to talk about Space Audits? I believe I recognize your voice.
Yo, what's up, man? No, Shane's the wobble lad.
Hey, I'm gonna share the mic. I'm gonna drop out, but I wanna close with this. I know that people have gone back and forth and debated this whole flat versus globe thing like crazy, and ultimately we're all looking for the truth. A couple legends that I look up to is Dr. Stephen A. Young and Mark Gober. Neither of them are, uneducated. Stephen A. Young, he wrote the book of Fool's Wisdom. You should check it out. He has a master's in physics and a PhD in nuclear theoretical physics, and he definitely knows we don't live on a globe. And Mark Gober, he graduated from Princeton, magna cum laude, and he wrote the book An End to the Upside Down Cosmos. I'm gonna have a stream with them pretty soon. Awesome guys, been emailing them. So yeah, this whole flat versus globe thing's not going away because people want the truth, and I think we've been lied to. But thanks, Globe Face, for being chill. It was nice talking with you.
Absolutely.
Yeah, dude, you got the Elmo wobble over there. Precession of the equinox, nutation, obliquity of the ecliptic, and the Chandler wobble, right? And the depiction on Wikipedia for nutation looks like a psychedelic gyroscopic fan blade or whatever. It's going in so many directions, trying to just do one of those motions that I don't think I've ever seen all three of these depicted anywhere.
Okay.
Well, that's it. That's, impossibility of a rotating sphere.
Why is it impossible? Because you showed some pictures. I don't get it.
Well, no, I'm asking for a depiction of it, right? People say it's mathematically possible, but no one's
Okay,
ever
so
shown it.
if I
in
show
any
you a computer
animation.
model of it, will you say you believe it?
Since
I
I
will
brought this
shut
up,
up.
guys,
I will shut up about it for sure.
It was presupposed off of one axis, and they're all spinning at different rates. So that's kind of impossible. Speeding up and slowing down on one axis, four vectors on one little on one ball. That's how can you?
Hello,
I
everyone.
can't even think about that. But
I mean, just saying it's impossible is not make it impossible. You understand that, right?
Yo, while you guys are chilling in the background, I got a video up of a boat on the horizon being
Okay.
brought back in from 80 miles. Here we go. I'll move this over so you can see it. Shout out to Mike
Why-
Ball.
Why is it nighttime?
I don't know. I just work here, bro.
Wikipedia.
It's going to be a little hard to see, isn't it?
I mean, we'll
Okay,
figure it
let's
out. I haven't seen this before, bro. I'm in for a ride just like you.
It says Milwaukee. Doesn't say a boat. It says it's a picture of Milwaukee.
Oh, he's not bringing in a boat. I'm sorry. He's bringing in the entire city. My bad.
Yeah, that's just making the city bigger too, but okay.
So 37 feet.
Keep trying though. Want to see
30
one be a first.
Well,
But
3,700
a city
feet
that's
should be
supposed
hidden.
to be hidden
Yeah.
behind ball curve.
Yeah, 3,007 feet of it. So
Is it?
Yeah, that's what it says.
That's what it says, but is it?
I mean, dude, do you want to play the is it game or do you just want to go calculate it out? Like I can send you this.
We can go calculate it out. You send me out because Taboo Conspiracy isn't known for his excellent research.
Actually, any time that I've ever seen him get corrected on a video, he actually retracts it. I know I can think of like at least over 5 instances where he retracted things that were wrong. So if you could actually point out why this is wrong, I'll contact him and tell him like it was wrong and he'll take it down.
He never admitted his Mount Canagoo observation was wrong.
Well, that's still a huge point of contention, and I don't think anyone's actually shown that that's wrong.
Really? Okay. So there's the ones with the quote unquote mountains behind Crete. There's one supposedly you're seeing mountains during a sunset over Crete. Yeah, those are clouds. I can show you they're 100% clouds. They move. from left to right as the sun's setting. They're not mountains.
Roby, would
didn't
you be
retract that.
interested in a celestial theodolite observation? Would that interest you at all? A theodolite observation over Pikes Peak? Could we possibly go over something like that with you? Would you be open to that, sir?
If it's the video Allan posted earlier today or yesterday, I've already watched it.
But can we go over it with you? This theodolite observation?
What are your thoughts?
If you like to, you can go ahead. My thoughts were I downloaded it to take a look at it later. I haven't got a chance to look at it yet.
Oh, you haven't looked at it yet? Well,
I watched the video briefly, but
right here, live. And get your comments.
Weren't you the one saying not to put people on the spot earlier? Wasn't that you? Wasn't that you saying it's not nice to interrogate people?
No.
And here you are. Maybe we should get your live reaction.
That was me, not her. That was me.
All right, I apologize.
That wasn't
but
me,
I'm sure
sir.
she was thinking the same thing.
But no, I was just wondering.
Oh,
I mean, if you would like to go over it.
We can watch it. It's his live. If you want to watch it, that's fine. I mean, this observation relies on
comedy, bro. You're comedy.
This observation relies on I haven't fully absorbed it yet, but you're also just taking his word for a lot of things. I didn't see anything but numbers written down on a page. So
I understand that. It is a lot of math. It is a lot of numbers and math written down on a page. So it does take some time to go over and understand and absorb what it is that Professor Mike has put forward here. It does take some time to understand it for sure. But I don't think that it is math that would be above your head in any way.
Well, he also used stellarium for his elevation angles at the top of the mountain. And I'm not sure, I have to look into that. I'm not sure how accurate that is, or if that's even possible to remove refraction out of their calculations, because I know he claimed that he did all that. He claimed he removed the refraction out of the stellarium program to show elevation angles without refraction involved. I don't even know if that's possible.
You can just turn it off. It's an option.
You can turn off the atmosphere, but I don't know if that changes the value of the elevation angle.
Yeah, this class performs the refraction computations, and you can just turn it off. There's a class for it. You just switch it off. Apparently.
Okay. Well, I have to look into all that. But yeah, if you want to play it, play it.
But yeah, that would be awesome. So yeah, we'll go over it.
Can I put my 2 cents in on stellarium?
Absolutely, go ahead.
It's my understanding that refraction is busted in stellarium. Don't work.
What's busted?
Refraction is busted in stellarium. It doesn't work. Like the feature itself don't work.
Okay.
I think it was Mctoons that told me that, because we were in contention about the observation of the Southern Cross from the Canary Islands, and he brought it to my attention that refraction is busted in it. But it ended up being, so there's other software you can use, like telescope aiming software. It's like called like C2A, and you can put in your elevation and your and you can turn atmospheric refraction on and off. So maybe
that part of it definitely has to be looked into.
I wouldn't rely on stellarium. It's kind of a toy.
I certainly would prefer, if he's going to do something like this to test it, to actually take the measurement himself, if he's going to do it. But I don't think he's going to climb to the top of a mountain, is he?
I'm like you. I didn't get a chance to go over it. I just briefly skimmed it. So, but I just think stellarium is not a good tool to be using to where the stars are.
Yeah.
It's because it's a toy, really. It's not like you can't aim a telescope with it. So.
Sorry, I mean, it's just the celestial sphere. I've never found a single wrong observation with it, but yeah.
We got to dial it back a little bit, because we're talking about apparent things again, guys.
But
we weren't
talking about watching the video. Could we go through possibly the observation again and just walk through and start it? Is that possible to start?
Do we need to watch it? He said he watched it already.
I think everyone here saw it.
No, I just meant walk through it. I'm not sure that everybody is here. Just what we walked through at the beginning. I mean, you may have, but I'm not sure that everybody has.
Yeah, just a quick recap so everyone knows what we're talking about. But also, Anyway, the Milwaukee sky. I was thinking about the Milwaukee thing. Okay, so anyway, we have Pikes Peak here from Colorado at 50.7 kilometers away, and he's going to go over the angles and math involved here. So I'm just going to scroll down. So getting his Lati and Longi there to get his distance from his house to get his bearing to the mountain, he goes over and determines that the theta angle here will be 2 degrees and 31 arc minutes based off the height of the mountain here being 2,226 meters and the distance being 50.7 kilometers. So he's got his theta angle there, and what he's going to do is he's going to measure a star being occulted behind this mountain, showing that this is physically there at this location based off of the flat Earth elevation angle. And then in addition to that, he says that when you have refraction turned off on stellarium and you put an observer at the top of this mountain, that this theta angle stays the same, indicating that that is the true elevation angle to the star, and it's not the contour of the Earth isn't curved away from you, because basically what will happen is, if that's true, these are going to make separate predictions here for the angle for the observer on the ground versus on the top here. And in addition to that, the refraction, because we're looking through the same optical corridor here, any refraction applied has to be the same. So if this mountain is in its true position and it occults the star, then that's actually where it's at in the sky. So we'll go through here, look at the tech specs, what he used. Someone's hot micing a little bit. Thank you, sir. So he used the David White 8300 theodolite. This is supposed to be like the best theodolite ever made or whatever. So he gives some tips on the tripod and stuff if you want to get one yourself. Anyway, it goes over the derivation for that angle again to get the 2 degrees and 31 arc minutes. And as he goes through, he shows the refraction coefficient that turns all observations into, it basically turns the difference into refraction. That's why I personally don't argue terrestrial observations, because the refraction coefficient will make up the difference every time to turn it into a planar observation. And if the two positions are, I believe it's a plane versus I believe it looks like a plane due to refraction, then those positions are equivalent. So it's hard to determine which is the correct position there. So that's why the star occultation is super important, because it's going to show that the exact position of that mountain in reality is at 2 degrees and 31 arc minutes, because it's going to physically block a star that's supposed to be in a different location based on the globe here. So as we scroll down, we can see the globe prediction.
Okay, I have a question.
Yep. 1 second. Here's pictures of the star being occulted, and then let me show the globe prediction, and then we'll do questions. Yep, here we go. So the globe predicts that this angle would be 2 degrees and 19 arc minutes, and they actually use refraction to make up the difference there. And then based off of the star there, if that's occulting it, it's going to be 2 degrees and 41 arc minutes. So it's going to be higher than what is actually measured there. And it's revealed that its true location is at 2 degrees and 31 arc minutes. Sorry, go ahead, sir.
So first off, I like the idea. I like where he's going with this. But my first question to you guys on the panel is he taking into account curved visual space and the fact that we have limits to our vision that make us see everything dropping in the sky like a globe? Because
yes.
If his observation is matching what you would expect on a flat Earth, then you're not seeing what you would expect on the globe. Therefore, it's not globe vision, as I call it. So it seems a little hypocritical.
No. So what we're looking at here is, you guys would say that, due to refraction, the star is actually in a different spot. And like normally you could get away with that, but the purpose of this is to show the difference. Now, when you say, did he account for curved visual space? Well, yes, by assuming that equidistant web for the location of the star in the first place, this is in relation to where it would be in your field of vision.
But I don't think so, because if it was, then it would have matched the globe prediction.
Oh, so here's the thing. The globe prediction actually only comes out of adding that refraction coefficient that was mentioned earlier. There is no globe prediction. And if that refraction coefficient were true, we would have 2 different angles produced here. So
we're not talking about refraction. I don't think you're getting the point.
No, I'm precisely getting it, because you're saying that the globe prediction is XYZ, but what you're not realizing is that the globe prediction is supplemented by refraction. And when you turn off the refraction coefficient in stellarium, it's just showing you the it's literally the same planar observations that he calculated. That was the whole purpose of him going through this at the beginning here, because this is the flat Earth prediction. This matches what stellarium shows with no refraction. And when the star occults this, in reality, it shows that that is the physical location of it, and it's not being refracted up.
But so what you're saying is what he's looking at here is not matching what we've talked about for the first 2 hours of this show. Well, not 2 hours, but you know what I mean. Like it should have matched the globe prediction without the refraction, or with the refraction. It should have matched it.
The globe prediction is just an elevation angle to the star. The supplemental correction for where it's at comes from taking zenith measurements and assuming either ellipsoid geometry or gravitational undulations.
Okay. So you he put refraction in there, I'm guessing, right? That's what you're saying, and that corrected for the globe observation to make it match the flat observation. Is that what you're saying?
I'm saying that the globe assertion of that refraction coefficient is false, because that mountain is physically there in that location to occult that star. That's why it works. That's why
refraction exists, though, right? I mean, you agree with that, right?
Absolutely, but to the magnitude that it's being applied to make the globe model work, it's clearly just a supplement. It's literally the missing difference in all observations to make it a globe. So without that, we're looking at a literal planar observation, and then for it to be occulted by the mountain and then still share the same relationship with the angle when you put an observer at the top would completely falsify the globe.
I think it would falsify your theory at the beginning of this chat. But he didn't go up to the mountain, right? He's using stellarium.
Yes. As far as I know, yes.
Okay. Yeah. So I don't think I'd believe that that's an accurate observation unless that was being measured both locations. But
that's a fair point of contention, I suppose. I would like to see him be able to go up there and do that as well, but it might not.
I mean, I like where he's going with it, but I think it's a bit hypocritical.
I'm telling you guys, we got you guys with the wobble thing.
So I just wanted to.
Oh my God, with the wobble thing.
I just wanted to reiterate though. So like, is your position that stellarium is incorrect then? Because he was using it to verify, and I've heard most people on the globe say that it's correct and can be used. And India was just saying that the refraction coefficient may be off, but we're dealing with the refraction turned off. So the globe should. Suddenly the globe is matching the flat Earth prediction with optics with using the same radius. You know what I'm saying?
The globe is matching the flat Earth observation. But
when you turn refraction off specifically, there was another part to that sentence that is important.
Oh yeah, when you turn refraction off, yes. But again, that doesn't make sense because it should be matching the globe observation.
Yeah, right, but in reality, though, the thing is, though, like this mountain matches that flat Earth prediction and occults it at that.
But there is no flat Earth prediction. Don't you understand? You just said there's no flat Earth prediction. The flat Earth prediction is the globe prediction. This was your whole argument for the last 2 weeks.
That's not what my premise has been. What we're talking about with the optics and the positions of the stars, we're saying you see this, and you guys are saying that when you apply corrections, that the star is actually in a different position. And this falsifies this because this angle here is represented by a physical object that is causing the obstruction. This doesn't exist. This geometry to create this doesn't exist on a globe. So your argument would have to be now that
sure it does. The mountain. Refraction applies to everything. Right? If you're looking at the peak of that mountain, it certainly would be refracting, right?
And the coefficient used to describe it is wrong because it would predict a different angle for that position of the star. We can see the other prediction.
What about the height of the mountain? That's what I'm saying. Did he take that into account for the height of the mountain?
That's part of how he got the angle. What do you mean?
What he pointed the theodolite at the peak of the mountain. It was like a building up there, right? He pointed it at some sort of building at the top of the mountain, and that's the peak of fire.
Well, he didn't point it at the building, but he was saying that you can see the building from the ground there because it's flat on top.
I thought that's where he took his measurement. All right, so what did he take his measurement to the peak of the mountain?
No, he was 50 miles, 50.7 kilometers away in his sunroom.
Okay, but so so how did he measure his angle to the mountain? He had to have lined it up with something, right? He lined it up with the visible peak.
Yeah, theater. Oh, yes. I'm sorry. Yes. You're right.
That's what I'm saying.
That's at the top of the mountain. That's square center at the very center at the top of Pikes Peak.
Right. And when he calculated that angle, did he correct for refraction for that angle? Or did he just do it with the star?
So he did it for both, if I remember correctly. And then the point of contention would have been like, if this refraction calculation is true, then this mountain won't be here to physically occult this star. And the fact that it was shows that the refraction coefficient that's used is unjustified to claim that it's a globe because this mountain is physically there. Like the purpose of this is to differentiate between the two because the globe only exists through mathematical corrections to positions of the stars and assumptions about the ground. And this shows that those assumptions are false and the corrections are the only thing that supplement the belief in the globe. Otherwise, the star would be there would be a different angle.
Well, like I said, you got to look through this. I think a major flaw is relying on stellarium for unrefracted elevation angles from the peak of a mountain. It's a very specific location.
Okay, so so real quick though, the globe predicts 2 degrees 17 arc minutes, and the one for refraction for the star on the globe would be 231. Now, when you put the theodolite to the star to make the measurement at the tip of the mountain, right? They all have to agree with the same refraction coefficient. And if they don't, then that means the refraction coefficient that you're using is wrong. So the raw star measurement of 2 degrees and 31 arc minutes is where it's actually at. The predicted globe refracted would be 2.46.
Okay.
So do we know the observer height? Because I've measured Pikes Peak before with the theodolite.
The observer height? Yeah, he's like, let's just say 6 feet tall.
6 feet from.
He might be on something.
No. So it did Denver, right? Denver, Colorado is about that far from Pikes Peak, right? And that's a mile-high city. So that observer height is kind of relevant to Pikes Peak's elevation, right, guys? I mean, you guys are the math guys. You know.
Well, yeah, you would need the relative height of the mountain.
Hold on, he used his GPS location to get to mean sea level. We're good.
Yeah. So off of mean sea level, what is the observer height on this theodolite measurement to Pikes Peak? Because that's very, very, very relevant.
Let's see.
I don't remember him saying that.
So a mile high, like a mile is 5,280 feet, right? Right, gentlemen? So what is the observer height going to Pikes Peak, which is what, 14,000 and some odd feet, right? Because that will be very relevant to the elevation angle that he
needs. What he needs is the elevation of Pikes Peak relative to his elevation to get the angle. Now, I don't know if he did that, but that's what he needs to do.
Well,
unfortunately, he did this to his house.
So we can read how he did it right here. So
the problem I have, Allan, with this is that, and I don't blame him, but if he gives us actual coordinates so we can, check the math, like we're gonna have his house because he did it from a sunroom. And that's probably not a good idea.
And also, real quick.
That's okay.
Real quick.
But he can give his elevation. I mean, he doesn't have to give his location. He can just give his elevation, right, guys?
Well, we need the distance, right? So.
Yeah, but that's fine. Give the distance and the elevation of your observer height, because you have to in order to get these measurements. You absolutely have to.
Yeah, I agree.
2,074 meters above sea level is what it says right here.
2,074. Okay, let me check that.
So anyway, stellarium also accounts for your elevation or height when you're when you enter your lat long. It has the topographical map built into it. But yeah, you're also someone's mic's going off a little bit in the background.
It's like
typically these star software programs, they use what's called the astronomical horizon for your level. So like when they tell you like a star is 2 degrees above the horizon, they're using the astronomical horizon, which is basically your eye level. They're not using like what they would call, fuck dude, I think they call it the rational horizon or something stupid like that. Astronomy's got their own terminology, like their terms of art.
All right, but yeah, we've been going for 2 hours now, so we're probably gonna wrap up in like the next 10 or so. So if you want to figure out your thing,
we gotta get this. We gotta get this wobble thing down, man. The sun was going too fast. The moon was going too fast. The stars were going too fast. And I forget what the fourth one is, honestly. But that's enough already. They can't get it down on a gyroscope. That's impossible.
It's a rough one. I would like to see it modeled.
Yeah.
Or whatever.
So it's like either everything's moving individually in the sky just based off what we observe, or you can't make it work any other way. Like, we could try, but try as you might,
You know how long those wobbles
I
are?
wobble like Elmo can. I think that's probably the best meme for that. Like, show us the wobble.
Did you know what the precession of those wobbles are on Earth?
Yeah, it's like thousands of years or whatever.
It's 24,000 years for the regular precession.
Yeah.
And then one's 18.6, but
So-
that's still speeding up and slowing down on one
Over
I mean,
24,000 years.
It
What do you
still doesn't
expect to
matter.
see
You have
in
to
the
scale it
sky
down
because
to
of that?
nine
No, it
because
does
of the
matter.
scales,
Well, listen, it's still it doesn't matter how long the scale is like at the time, right? It's still all tied to the same axis, which is super weird. Like that's why we're calling it into question because
And we tried with the gyroscope, but that's not even like close to like a spinning top. Like, how do you even make it work?
You're right, guys. They they made up all these impossible wobbles just so you guys could figure it out one day on TikTok. It's crazy. It's crazy talk.
I mean that's not a good argument.
Like other astronomers have noticed that the problem with the wobble, the precession of the equinox, doesn't apply to planets. And that it only applies to stars for some reason.
Yeah, well, a good argument is not saying it doesn't work because it doesn't work.
Yo, for real, India? Who
Well,
said that?
yeah. I can actually give you published peer-reviewed papers from astronomers that have pointed this out. They've known about it for hundreds of years. It's a problem.
Yeah, please, dude, that would be great. That's awesome.
So whose data is this that took this measurement? Because my measurements from 56 miles away, I was 5,550 feet. So this guy was 1,300 feet above me from closer to that peak. So I'm wondering exactly where he was. I don't expect him to give
50,
us where he was.
50 kilometers, but not 50 miles.
So what did that equal? Like 30 miles? 50 kilometers is what? 30 miles?
31 miles, someone's saying in the chat. It's 50.7 if you want to get precise, but
yeah, it's 31.5.
Feel the scrambling on a vibrational level.
So he was
per square mile.
So he was 31 miles, and he was 6,800 feet. I was 56 miles, and I was 5,500 feet. So he's 1,300 feet above me, and he's closer to that. That's a lot of difference. But let me see if that math checks out. 6,800 feet.
I'm telling you, watching this after I just said the wobble thing is like, you guys are done. You guys are done.
It's such an odd thing to harp on. I can show you a rocket video from space of a private citizen, which I showed some of you guys the other day, Allan.
Yeah. Yeah, I don't contend that you
Okay.
can send a rocket up and see things. Like that's not.
What kind of camera did he have on it?
A GoPro retrofitted with an M10 rectilinear lens.
Like optics doesn't just magically go away.
Doesn't matter. No
I
lens
love
is
your chill
rectilinear
vibe,
when it's
space
used
audits.
outside of its
Wait, I want to hear
It's
what
just
the name of the camera
okay.
is. And I want to see the
Yeah,
video.
so no lens is rectilinear when it's used outside its specification.
Excuse me, say that again.
Yeah, no lens is rectilinear or stays rectilinear when it's used outside its specification.
What's its specification?
Well, it sure as hell wasn't designed for near vacuum with -50 degrees centigrade fucking temperature.
So the air
so
pressure around it is now affecting
Yeah, it does.
affecting the rectilinear's lens and making flat Earth a globe.
No, I can send you papers. It's called Design Steps for Temperature Insensitive.
Okay. Yeah, you send me a picture.
Devices. No, I'm going to send you a paper.
That's what I just said. Send me a paper.
When they design these things for high altitude aerial photography, they have to design them to compensate for the temperature and the increased because the refraction of the lens is a relative value. So it's
increasing with altitude now.
No, yeah, exactly. So yes,
interesting. I thought refraction decreased because air density was decreasing, but I guess it's increasing now from space.
No. But listen closer. It's the relative value.
Mm-hmm.
The relative is a relative value. So you have the air has a refractive value. The lens has a refractive value. When you go up in altitude, the refractive index of the air goes down. So now the relative value of between the lens and what's outside the lens increases. So when the light goes through the lens, it does not preserve the same geometry that it would have when it would have been on the ground.
Yep.
You
send me that paper, Indy.
And it projects the image, which has what's called Petzval curvature.
Yeah.
So it creates like a meniscus image on the sensor because now it's outside its design spec.
Right.
Yep. I forgot we were spinning.
I'll read it to you. I'll just read
What's the name of it? I'll look it up right now.
Yeah. Hold on. I just want to get it real quick. Hold on.
I mean, Allan's going to chop off in a few minutes, but I want to read this. This sounds amazing. So, it's taking a flat Earth and distorting it because the refraction of the lens.
So a straw man. That's the best you can do is to make a straw man.
I'm trying to steel man your argument right now.
No, you're not.
You tell me where I'm wrong.
I said the geometry that you're seeing is not the
correct.
actual geometry. That's right, and it has nothing to do with flat Earth or not. It has to do with the true geometry is not preserved because you changed. So when they designed the lens for one condition, you changed the condition from which it's operated, and now the geometry that it would be in one state is not in the current state. And the name of the paper is Design Steps to Pressure and Temperature.
Hold on, slow down.
Okay.
What is it?
It's called. It's by a guy named Yilmaz, Yilmaz. Is Yilmaz O al. Design Steps to Temperature and Pressure in Sensitive Optical Systems for Digital Aerial Imaging.
Yeah, I kind of said.
I can read you right from the paper. The effect of pressure comes when relative refractive indices change due to air pressure. Actually, refractive indices of materials are defined relative to air at a reference temperature and pressure. It is said absolute refractive index. It means that reference air pressure is zero vacuum. Relative and absolute refractive index depend on each other as follows. When they give an equation, this means that when the materials are put in low pressure environment, their relative refractive indices increase. Since absolute index is constant and the low pressure means low refractive index air. This causes increase in refractive power of the system and therefore causes defocus. And if you go defocus, it has this defined is Petzval curvature, which creates like a meniscus type surface in the image.
Okay. Do you mind saying that name a little bit slower for the third time? I'm trying to type it, so you got to help me out here.
Okay. Design
steps. Yeah.
To temperature and pressure. Insensitive.
Oh, can you
optical
mute the
systems.
typing, brother?
I can't. I'm typing as he's talking.
Where are you at?
It's me.
Are you at optical systems?
Pressure insensitive.
Optical systems for digital aerial imaging. And it goes through all the factors that you have to design. Typically, what they'll do is they will design it for high altitude, and what they'll do is they'll make a hermetically sealed interior, right? So that like inside the system itself, they still got to deal with like what's outside the lens, but you have the problem of what's inside the lens and what's outside the lens if it's not sealed, right? Because of the temperature. So if they seal it so they don't get, because the temperature also changes the dimensions of the lens physically, and it changes the dimensions of the entire optical system physically. And if you're doing high resolution freaking imagery, then that's like, you know, a problem.
Okay, so your claim is that even though we can watch this video from a rectilinear lens and it matches the globe curvature as modeled at every step of the way. Walter Bisland's model.
Yeah, that's trash.
Oh, it's trash. Okay, sorry.
Okay, so tell me when I click on the theodolite feature and it says it's pointed at eye level, it points at the horizon. Tell me why it does that.
No. I have a theodolite. It
So
doesn't
I
do
can
that.
I can see here and go over all sorts of problems in business model. I'm not just saying
have
it
a
because
theodolite. It
I don't
doesn't
like
do
this model. I can go through dozens of problems with it where it doesn't work.
I have a theodolite. It doesn't do that. And even Taylor has one. She knows that doesn't do that too.
Yeah, dude, like we're talking about something else.
Check this out. Check this out, guys. Pikes Peak is 4,302 meters, right? It's not 2,074 meters, right, guys? Pikes Peak is more than twice the size that you guys pulled up, right?
Oh boy, is that true?
Make it worse.
Yes, that is a fact. Pikes Peak is 14,115 feet, which is 4,302 meters. It's not 2,074 meters wide like you guys brought up. So what's up with that?
All right, let's double check. Did he say, what did he say the height of Pikes Peak was in that?
Was it subtracted from his height, from the observational?
So he says the visitor center is at 4,300 meters, 57 from me to at 2,074 meters. The tangent of that, 4,300 minus 2,074 divided by 5070, 700.
Yeah, see, he did measure to the visitor center like I thought, which I guess is at the peak. It looks like it's at the top there.
Yeah, my bad.
43.
So he said 4,300 meters, and you're saying 8-inch?
Yeah. So it is 4,302 meters.
Yeah, so we're good.
So what I got with the numbers you gave me is 4 degrees, 39 minutes, and 21 seconds. And his conclusion was half that.
Are you able to send me what you got? Can you take a picture of it and send it to me?
Yeah, I could do that.
Or if you could,
it's 31.5 miles, which was how many kilometers? Right.
50.7 kilometers.
50.7 kilometers. Okay. So let me turn my camera around. I don't have to look at my ugly face.
We love the honesty. Let's keep it up.
Right. So 50.7 kilometers is 31.5 miles. That's what I got, right?
Yep.
And Pikes Peak is 14,115 feet, which is 4,302 meters. So if I'm, and then his observer height was 2,074 meters, is that correct?
Yeah, Globey, I'm going to mute you for a second while you're typing.
Was it, so the observer height was 2,074 meters? Is that right?
Yep.
Okay. So if we're 6,804, let's just verify that just to make sure I'm not messed up here. So 2,704, 2,000 meters to feet. That would be 6,804 feet. Okay, now we're rocking here. So 6,804 feet, and the distance is 31.5 31.5 miles. Excuse my sloppy handwriting. 14,115 to Pikes Peak. And it's just, now we have a triangle, right, guys? So I'll just subtract my height. 14115 minus 6804. So 7311 divided by 31.5 in feet, 31.5 times 5280.
Like birds love to fly, they think it's fun to fly. That's what we're doing, but we gotta come down to the ground level and realize that these wobbles, you can't.
I've been
Can't
wondering
escape
about
the
these
truth of it.
wobbles. They're crazy, aren't they?
Yeah, man. They're
Wobbling.
crazy.
I'm busy actually right now.
Elevation angle is 2.5. We'll call it.
While he's doing that, I'll say, unless I'm doing something wrong, I went into Stellarium and put in the latitude and longitude for Pikes Peak, and it's telling me the elevation is 1636. So
1636.
I can manually change it. That's not right. Still, it didn't move. I put in Denver, Colorado, and it didn't change when I put in the exact location for Pikes Peak.
I went to Pikes Peak.
I'm not sure this thing is.
Okay, so I got on a
Well,
flat
there's a
Earth,
lot of places named Pikes Peak, so I mean,
if the Earth is flat, that elevation angle would be 2 degrees 31 minutes. 1 arc second.
Yep.
From his location.
That's what he calculated out.
Okay, so where's his measurement at? Let's see the measurement. Or does he not have that information or a video?
Oh, you mean like
He-
a video?
he didn't
of
show
him-
it.
Yeah,
He
you
didn't
mean
show
like, Yeah, you mean like a video of him doing the measurement? No.
Okay.
It's kind of a trust me, bro kind of thing.
Well,
in his presentation, he said that he tried to take a picture to the theodolite, but it wouldn't come out.
Yeah, he
Okay,
does
so-
give us a picture of his telescope though.
If I'm not mistaken, I did this and I got it on video, right? And I did the flat Earth, the flat Earth prediction, and then I got my globe Earth prediction, and then I showed the video. I could probably go and look for it and find it. I do this all the time, right? I just I've got so much of this stuff.
Yeah, no worries.
Because I have a theodolite, and when you have a theodolite, you just record all the stuff you do, and then you can just bring it up, right? Right, Taylor? You have a theodolite, right?
Yeah, do you have a modern one? Because he actually bought a.
I have an old. I have an old one.
Oh, nice.
He's on lunch break.
Yeah, he's got the old David White 8300.
Yeah, I mean any theodolite will do, right, guys?
I don't know. He said he had
Depends
trouble
on-
recording out of it, so I've never recorded through one. I have no idea.
It's an old manual one.
It is rather difficult to record through these. I gotta admit.
Oh, okay.
Taylor knows. Taylor's got one. She knows.
All right, lads. We are going to wrap up soon, though.
Okay.
We hit the limit right when you were doing the math, though. So I wanted to let you finish out. Is there anything else you wanted to add to that, or you said
No.
you basically calculated the same angle, though? More or
I
less?
you know what? I got 2 minutes or 2 degrees 31 minutes. So I don't recall what he had, but that was pretty close, right?
Yep, pretty much on the nose. Cool.
Okay, so on a flat Earth, that's what it would be, and I would love to see him measure that. Yeah.
Awesome. I will put in that. I will put in that request to get the exact measurement. Okay. So what you want, like the
just a video of him measuring.
Gotcha.
Yeah.
Got you. Absolutely. Will do, bro.
Okay.
Will do.
Right on, dude.
All right. So Globe, you still here? Do you have anything coming up this week? Do you want to promote or anything?
I got a debate with someone Monday.
Nice.
I think if it's not on my channel, it'll be rebroadcast on my channel on YouTube. So if anybody wants to watch that, that's coming up around 9 p.m. Eastern. That's about it.
Nice. All right. Cool.
Thank you.
8 inches. Thanks for coming on. If you have anything that you want to promote.
Yeah. No, I'm good.
You're good. All right. Cool. And then.
Oh yeah.
Judinsky, thank you. You knew I was struggling to get there. I was like, Judid.
Yes, sir.
All right, what's up, bro? You got anything you want to talk about?
Yeah, in closing, like Austin Winsett said, the 2.34 axis was observed on a non-local observation, and that means that it's something way out there, and it's not something that we can, what's it called, say that is a part of our whole spinning globe. Yeah, we can't. Yeah, it's hard to explain this type of stuff.
Right on. Too many wobbles for one axis, you're saying.
Yeah, you said it.
Gotcha. Taylor, what do you got coming up on the 11th of this month?
I'm going to be presenting on abiogenesis.
Where are you going to be presenting that at?
On Ether Cause.
Nice. India, what do you got coming up, brother?
Oh God, I don't know.
Flat Earth Friday return?
I'll be on Discord. Oh, Friday? We returning Friday? You got Flat Earth Fridays going?
I don't know, but I assume when they do return, you will be there.
Oh yeah, certainly I'll be there. In between then and now, I just chill at the politics server and deal with those people. We got a channel over there, so it's an endless stream of, globe champions. Let's just call them that. I'm being nice.
Awesome. Kat, what do you got
Champions
coming up
of the globe.
week?
I think we've got a little game action going on at Ether Cause, and we'll have Ether Cause community game night next Monday. But I do want to give a shout out to those people that are gifting the 4 members of Space Audits team, because we are new to this TikTok stuff. But Jean Techman, Proud, Katie Didn't, and Glenda Safkin are all the 4 members on Space Audits team. Thank you guys. However you're joining, for all the gifts and whatever that are sent up. We are new to this and don't know exactly how this all works, but thank you for all who are sending stuff up, and we appreciate coming and sharing the time with us, sharing the live out. Yeah. Thank you all for come to listen.
My boy Xavier sent a lightning bolt and a rose. What's up? Very cool, brother. All right. So for the rest of the week, we got Friday events, so that'll be probably a community space or Flat Earth Fridays. Monday will be community Ether Cause. Tuesday will be Taylor presenting, and then Wednesday and Thursday will be more TikTok stuff. But before we get to all of that, Sunday will be.
I guarantee you start looking into this, it's going to all fall.
Dr. Mike Heffron's presentation on Globebusters, presenting the celestial theodolites. So everything we went over earlier, he's going to be going over in more detail. And I'll see if I can get him to do some supplemental measurements to appease everyone, because those are some valid
stellarium thing, because I'm looking at it right here.
So those will definitely be met. Thanks everyone for tuning in. We'll see you guys for the next one. Later.
Can I move this? Oh my god, how do I move this stellarium to my other screen? Oh my god, I can't. I can share this screen though, can't I? Display capture. Scepter. There we go. All right, so yeah, I put in the coordinates here. Oh, let me stick the OBS over here. So, right up here, these are the coordinates for Pikes Peak, and it's telling me 1636. So, how get location from GPS? Okay, I can't do that. I mean, I can change this manually, but why would I do that? Like, did he have the right information in there? And does that change the information to the star? I need to know what star it is now. God damn it. I have his video, I think. Oh, I'm going to tear this thing apart once I start digging into it. This is what they want to do, though. They want to, like, throw some shit at you that you haven't had time to look at. And we're supposed to believe a flat earther's measurements just... I told you so. Yeah, believe me, bro. I took these measurements. They line up perfectly. I'm a flat earther who can use a sextant. Because those are just running rampant everywhere. Flat earthers that can use sextants. Where's that video? I don't know. Let's see. What the hell would I put that in? Downloads. Here it is.
Whenever you're ready, sir. This will be a live recording. Whatever. Go ahead.
Let's see.
Where do you want
we
me to
need
start?
Let's see.
If I remember.
Is this his video? Yeah.
Go ahead.
Let's see.
Where do you want
we
me to
need odds one, but also mutually exclusive. Stated as something not mean free of hill is true to demonstrate H naught generally considered
Conveniently, Rocky Mountains. Okay.
One moment.
It boggles my mind because now and he tried to deny it, but now he's arguing that when you look through a theodolite, it matches the flat Earth observation. When this whole time he's arguing when you look through theodolites, you'll get the globe prediction because the Earth has an optical equivalence. It's flat, but we don't see a flat Earth because we have an optical equivalence. Now that optical equivalence doesn't exist. It's no more optical equivalence, guys, because now we have a measurement that matches flat Earth, supposedly. He should have taken the optical equivalence into account here and tied his two theories together. Oh my God, and that was great with that guy. He has a paper that shows that lenses distort in the upper atmosphere or in low Earth orbit. Wobble. So what do we got? And I was trying to be nice, guys, so don't hate on me. I could have went after them a little bit more, but I'm trying to be nice. I'm trying to get some flirt friends, if you know what I mean, over on YouTube, trying to make nicey with a few of them so that I can get some action going. You know what I mean? Catch more bees with honey, if you know what I mean. My chair is wobbling out of control. Do you believe the audacity to take Rayleigh's criterion, solve for theta, and just say, yeah, because I did that, I'm just going to say it's the limit of my vision? And they just run with it. All right. Sorry, I'm supposed to be looking for the star. Now I'm ranting. I don't see anything about the star here. David White, I want to look into this theodolite too. I'm going to send this to my buddy Barron and tell me what he thinks of this instrument. It's clearly an antique. He does take the time out to say it's the best theodolite ever made. I'm sure that's true. Many people claim this model is the best theodolite ever made. The first thing I saw when I Googled it was someone saying it's a great theodolite for building, not for elevation angles of stars and stuff like that. But I don't know. I don't really get that comment, but I want to get a professional's opinion on this theodolite. He even says it's slightly tricky to operate. And gives you a good look at the dials. The dials look... Why is this so cut off?
Now he's got this vernier scale on it. This is just showing how it works.
Oh, it's in the vernier scale. That's why.
How is the precision of his measurement, right? So it's also slightly tricky to read.
So we're going to assume he adjusted
Basically,
that all
it's
correctly.
the vernier scale on the ball.
People who
So
don't understand what a shadow is are operating this
tossing
equipment.
a telescope
All
or
right,
a theodolite.
here's the visitor center.
At
Okay,
night,
we
the
gotta go look at
observation
that.
room on the far left is lit. Oh, you got it up there. Visitor center is 43 minutes
So that's
with his
right.
telescope. And You got the
altitude,
altitude, latitude, and longitude
means
from
elevation.
Wikipedia.
It's true.
Altitude,
My
latitude,
satellite
and longitude
measured.
of the center should be
He's not going to say what star it was he? Is he?
Total 230 accurate.
Now we have
first
to
measure.
believe he was
That is
even
only
looking
one
at the
data
right
point, but there are
star
many more to
and
come.
getting the right
Now
star
it gets
into the
better,
lunar.
and that affects what you see. Formula curve looks flat, and that's due to atmospheric refraction to within the accuracy level plane between me and Pikes Peak. And if I get an even more expensive theodolite, critics will then claim atmospheric distortion null hypothesis, not globe. Falsity of their own null hypotheses that Earth not globe. How would they go about falsifying?
Oh my
Are
God,
the
he's
many correction
blabbing.
factors that they need in order
Where's
to
the
explain why
data?
the measurements demonstrate hypothesis perspective helps to highlight the absurdity of their arguments. Both flat and globe
We can
Earth
do
advocates
better.
agree
No,
that the
you can't.
position of the stars
Let's
in the
assume
sign to
globe.
explain
Pikes
then
Peak.
theta on the peak will be larger,
All right,
and
assuming
theta
I'm
at the
observing Pikes
telescope will
Peak,
be
including
smaller.
stars from my house.
Assume
God,
that he's
you're not
talking
gonna
about
say what
left
star
and
it
right
is.
based on drawing a circle, of course.
Oh wait, telescope.
Pikes Peak, the flat. Then an observer on top of Pikes Peak should observe the star at that same 230 second time seconds of the quarter telescope. Watch the mountain peak occlude stars. We can defeat the globers using their
Set
own
location
tools.
and stellarium to the
Telescope.
peak. Turn
Watch
off
mountain peak
atmospheric
occlude
correction.
stars.
Read
Stellarium.
elevation
Set
of
location
star
and
from
stellarium to the
stellarium
peak.
display.
Turn
What's
off
the damn
atmospheric.
star?
This is the point where it is wise to defeat the globers using their own tools. That puts them into the position of having to argue their own tools are no good in my Chromebook. With proper configuration, stellarium shows the elevation of a star when the peak occludes it in my location measurements from the peak, because it assumes will allow you to the following results may cause gate. The Earth is flat. The time-lapse video was 2 minutes of viewing the Pikes Peak Visitor Center 50.7 kilometers west of my house. A jet flew from south to north about midway through the video, but this
Here we go.
was my first
39 Aquari. Oh, here's the date. Look at him with all the information. That's rare. All right. So there it is for everybody. 39 Aquari, 6:27 p.m. on January 31st, 2025. If you're playing along at home. So January 31st. $2025, 6:27 p.m. Oh, that's AM. All right. All right, let's search. Let's see what we got. If it's as easy as doing this and he's wrong, I'm gonna laugh. Query, 2 eyes. Oh my God. Are you seeing this? My head's in the way. Where's the damn elevation? What do you say the angle was? Maybe this is just a scale thing. Hold on. Hold on. It can't be this easy. Pikes Peak occlusion elevation, 2 degrees, and maybe it's right. 2 degrees, 46 minutes. I haven't used this that much. Where the fuck is the elevation? That's all it's giving me? Solar, lunar, angle, set. What am I doing wrong here? Time zone wrong? This sets the time zone for the location, I believe. Stellarium adjusts it for the location you're at. Star does move when I turn the atmosphere off. So I'll give them that. I don't know if the data's right, but I see it moving physically. Oh, my head's in the way. Star's right there. Shit, I lost the star. That ain't it. So there's the star. Turn the atmosphere on and off. It does move up and down a bit. But what does it do to the numbers? All right, so height, here's the altitude there. So the apparent altitude with the that on, okay. The altitude is 2 degrees 36 minutes. Is that what he said? No. What does this mean? From the top of Pikes Peak, Stellarium says the occlusion elevation of several dozen stars was 2 degrees 46 minutes. What does several dozen stars mean? Oh, from the top of Pikes Peak. So that's where I am right now, supposedly. The top of Pikes Peak, according to my Latin Lounge. All right, so it was 4,000 meters, did he say? I want to see if I put 4,000, if this changes the elevation angle. Where's the altitude? It's 2 degrees 36, 52.6. So if I'm putting, I'm just going to put in 4,000. Okay, that did not change the altitude of the star. That didn't change the altitude of the star. It has a minus 14 declination. It does. Well, that's where globe vision comes back into play. It's globe vision for that argument, but not globe vision for the other argument. Yeah, so, yeah, it shouldn't. I wouldn't think it would, right? You're not going up. I mean, the amount you're going up from the ground to the top of a mountain is insignificant. I wouldn't think it would change, if anything, very, very slightly. So what is he doing in his math? Let's see. He's up to something. He's up to something, and I'm going to figure it out. I like the way he said, thereby accomplishing my goal. So he set out with a bias to begin with. All right, here's the picture. So that's the prediction. And he's saying because Earth's a globe and the mountain should be tilted away some degrees, that would change. Oh, Jesus, I wasn't even thinking that through. That's really what he's saying. Globe vision is the new post TFE cope. It is. It is. Oh my God. So let's go back to this. where's his prediction? So he thinks the prediction should be. Does he draw it out? He thinks the prediction should be that because the mountain is tilted away slightly on a globe or a little bit lower, that the angle should be different to the star? Why would that be? Oh my God, this whole thing it's irrelevant. This whole thing is irrelevant. Good Lord. Fuck me. If he walked over to that mountain and took an elevation angle to the same star, it would be the same number. It would be the same thing. It would be, 2 degrees, 31 minutes, or wherever he measured. It would be the same thing. If he did that at the same time of day, same date. That's crazy. Now I'm trying to. Now I got the wobbles. I'm trying to really think like a flat earther here, though. I swear he drew this out on the globe. Let me see if he had a picture. I need a picture. Was that it? No, that wasn't it. Oh, that's it. It's right at the beginning. I mean, he didn't really put the angles in there. But he's saying if the star is occluded over there, then the angle up from here to the star should be. Oh, sorry. Holy shit. All right, so that mountain was how far away? And what's the angular distance over? I mean, Jesus Christ. Oh my God, I can't believe it. I can't with these guys. What's the RZA for 50 kilometers? Is that what it was? It was 50 kilometers? I mean, we can just figure it out. It's about 31 miles, and then that's 69 degrees. So, I mean, it's less than a half a degree. It's less than a half a degree. So he thinks because the globe predicts a half a degree of tilt, that's going to affect the elevation angle to a star that's 400 light years away. Interesting. Crazy talk, man. These guys are special. All right. Anyway. Back to reality. Oh, this goes gravity. Yo. All right. I have to update this chart, by the way. I didn't forget you guys who contributed. Thank you. As a reminder, haven't hit the goal yet. Close to 25. First 25 members are going to get memorialized on my background. So thank you for that. If you'd like to support the channel, it helps me continue to do this, and gets my wife off my ass for wasting so much time talking to flat earthers. I just can't help it. Yeah, that's what I mean. Well, that's why at one point I brought up the rocket launch. All flat earthers want to do is get lost in the sauce in refraction observations. It's all they want to do. They just want to argue endlessly about refraction in a loop. Here's a thing. I see too much of this oil rig. Refraction. Oh, refraction. It can't exist. You know, Snell's law doesn't even work in the atmosphere because you need two mediums. If I hear that one more time, I'm going to bite a flat earther right in the face through my screen. So yeah, I still haven't fixed the fisting. And yes, I do promise you'll all get fisted. So yeah, so I tried to show him that rocket launch, right? That Kip Durgadas, his rocket launch. Everybody should know it by now. They can't answer this question. That's why this guy has to bring up lenses don't work now. Lenses don't work. I can't wait to read that in its entirety. I guarantee that doesn't say what he thinks it says. I don't know. Did anybody read it? Well, I sent the link out there. Did anybody read it while we were doing this? I was all over the place. I was trying to read that, and I was trying to get the coordinates for Pikes Peak and put it in, figure out stellarium. All right? They can't answer this. They have to now invoke that a rectilinear lens is completely distorted up in low Earth orbit. No matter what it is, it's always an excuse. It's globe vision, lenses don't work, CGI, it's fisheye lens. Provably not any of those things. What camera was it? As if they've ever once shown a camera in any of their high altitude balloon footage that they try to show. Not once have they ever shown the camera. What lens was used. It is a rectilinear lens. Oh, thanks for membership, me. Not me. Appreciate it. That's memberships and vibes as well. Mention that. Take that to me. Yeah. So why? How could he use that?
293.5, dude. 293.5. Coming down. 293.5.
Holy smokes! Almost 300K. Woo!
That's badass.
Is that a 418? Keep it running. This is too good. 293, Kip. Mach 41. Get this thing back. Woo!
All right, it's on shoot, so let's cut the drogue out.
Yeah.
Holy smoke. That's an Air Force definition of space, Kip.
It just slowed down.
That's the Air Force definition.
Yeah, we still, the main still hasn't come out yet.
Still in the materials.
Come on, baby, just pop that main. I know it was tight, but you can got it. You got it. Come on, come on, come on. Pop it, pop it, pop it, pop it, pop it.
So everyone be quiet.
These design principles are also valid for
Main parachute deployment charge has fired. Descent rate indicates main parachute.
Working environments
yeah.
is what? So far, they're only talking about resolution.
And we are out in the middle of nowhere looking for a rocket, and Google's saying 10 miles in 49 minutes.
Apparently, 7.7 miles away.
Yeah, you know what Google's trying to do is it's probably predicting like a gravel road at 10 miles per hour. Probably what it is. Yeah. Probably when you're going like...
No, it's not really dropping the time.
No, it's not. I don't know what's going on with that.
So
Here we are in the middle of, behind the farms in Blackrock's over there. These are going to be epic.
All right. For those of you who don't think rock.
Sorry about that. Better? I forgot it was still playing. My bad. I can't hear it on my side, so I don't even know when that happens. I should probably turn this monitor on. It is on. Why is the monitor on and I still didn't hear it? Why is that? Oh, it's set up as my speakers. All right, that's why. Okay. Sorry about that. Can you hear me now? Can you hear me now? Oh, now I gotta raise my volume. There you go. I want to go on Tunes Live? What is he doing? So you lit at me. Thanks again for the membership. Okay, so this whole thing is talking about defocusing. This whole thing's talking about defocusing. Oh, that's right. He's doing his live Q&A tonight, huh? Yeah, I'd go on Tune if he's up for it. Why not? I've been drinking a little less than nothing than I was last time I was on Tunes. We were up too late. When it gets to like 2 a.m., 3 a.m., man, between being tired and having a few beverages, starting to get delirious. I think at one point we were talking about cats shitting, pulling poop out of a toilet and throwing it in a kitty litter. And cats dying, all sorts of crazy shit. All right, so this wasn't planned, so thanks for showing up. I was just, I don't know what I was going to do tonight. Honestly, I didn't want to step on Toon's feet, so I wasn't going to do one. I wasn't even going to do one, kind of share an audience. So, but then I saw Allan on and Shane on TikTok, and I had to jump in because I wasn't sure whether I'd get another chance. Because I've been looking into his whole Rayleigh's Criterion thing again today, and I just had some glaring questions I wanted to ask him, which he couldn't answer. Who the fuck is texting me? So it's like my work Teams is going off. It's 11:30 at night. Why is my Teams going? Like, who's freaking texting me? Sorry, I don't know what's going on. I don't know what all those dings you're hearing are. How many of the flirfs you interacted with do you think are just mentally ill? a lot of them are mentally ill. Speaking of mentally ill, I do have a debate scheduled for Monday here, 9 p.m. Eastern, with a guy named DJ something, YouTube, TikToker. I mean, he's might slightly be mentally ill, but you know, you'll see. I think most of them are, and then you have ones like Allan, right? Space Audits. They confuse me. Because he seems like he understands more than he should for being a flat earther. So I don't know what his goal is. I don't know what his deal is. I don't. Like, I don't want to say he's too smart to be a flat earther, because I don't really know how smart he is. But he speaks intelligently. He's not a crazy flat earther, right? He's not like, you know, coming in and yelling and gish galloping. He's not one of those flat earthers, which most of them are. So I don't get it. I don't get what he's up to. To me, I think he's, in my opinion, I think he's just grifting. Because there are those groups of people too, right? Like, so, yeah, it might still be up, is it? Yeah, Rayleigh Criterion. Yeah, I was looking at these. So this is his website. So this is Shane's website, right? He's got all these things here on the left. All these coordinate systems, and then there's all this information here. He's taken time to at least put this together. Hold on, my green screen's screwed up. I can move my camera. There you go. So he's taken time to put all this together, right? So he's not, I mean, obviously he could just copy and paste this and have no idea what he's talking about. And maybe that's the case. Quite frankly, I think that probably is the case, right? But he's read all this, I guess, at some point, enough to regurgitate it. But he took the time to put this all together and at least copy and paste it from wherever he did. And it's pages and pages and pages. Like, who has the time for this? Look at this. Who has the time for this? And what does it mean at the end of the day? What does all this mean? Look at this little chart here. I can grab this thing and move it around. I don't know what that does. It's pretty cool. I don't know what the point of this is. Can I go places? Oh, look, it takes me places, but you can't read anything, so how do you know where it's taking you? I don't know what all this is. I don't know. The point is, if they put a fraction of the effort into this, into something like useful, like building a business or getting a job, like, you know, figuring something actually important out in the world of science. Maybe some of them could be dangerous. Some of them could get something done in their lives, right? You know, and then you have the other half who's trying to make money off of it, like Weiss and Whitsitt and some others. So I don't know. Just a couple groups. Yeah, he definitely. Yeah, I would definitely, not knowing any of them, would say he's trying to be like a Whitsitt type. For sure. Right? And those guys are the most dangerous. Not because they know what they're talking about, but because flat earthers put them on such a high pedestal because they sound like they know what they're talking about. Like, if I was a moron and I thought the earth was flat because someone told me it was, and I was looking for to confirm my bias, like, give me some information. I need something to confirm my bias. This would be great. These kind of websites would be great. I'd be in here like pretending I'm reading this and understanding it. Oh my God, they even have the AE map scale on here. 0 miles at the South Pole. Yeah, that's the scale. That makes sense on a flat Earth. That's just an optical equivalence, guys. Because I said so. So, yeah, it's great information. And I could just copy and paste a link and go, yeah, you're wrong because here's the link. Rayleigh's Criterion. This is just how our eyes see. It's optical. But I will give Allan credit. He's a good host. From what I've seen, he's not afraid of the conversation. I don't see him just blocking people. And the best thing he did tonight is he shut down Nathan Thompson. Nathan came in trying to do what Nathan does. Bulldozed alive. I don't know if he's a mod on that channel or not. If he is, he would have kicked and muted me and the others already, so he's probably not a mod. But and Space Audits just kind of shut him down, which was nice to see. Anyway, all right. Thank you guys for stopping by unexpectedly. Again, Monday, 9 p.m. Eastern, there will be a debate, unless he backs out. So we'll see. Should I give you a preview? Let's look at his page real quick. See if it's saved in here. Nope. Look at my messages. Shit. Hold on. Please hold.
Grab your
DJ Dyko. DJ Dyko. DJ Dyko. This should give you an idea of what's in store for Monday. Cool lap bars. Thank you. I honestly have no idea what I'm in store for. I've only interacted with him a few times on TikTok. He can get a little ranty, if you know what I mean. Goes off on some rants. So it might be a shit show. He says he wants to do it organized and stay on topic and do all that, but we know what happens when shit hits the fan. Could go sideways, which it makes it all the more fun, I think. So this isn't going to be a. I'll stop talking. I'll be nice. Let's be nice. Jonathan Morandi? Who's that? He's a TFE flatty? I'm confused by that comment. And let's see. I don't know what this video is. Let's see. Muted? No. Can you guys hear that? This thing confuses the crap out of me. I won't lie. Hold on, I gotta change the headphones to... No, it's headphones. Oh, I gotta change my system speakers to match that. Hold on. There we go.
Google Meet if we need more.
I gotta change the speaker settings in like 4 places.
There's no live feature to watch whatsoever. So I've been doing debates. Earth is Flat Bro, DJ Dyko, Facebook, and YouTube. Go check it out. Facebook and YouTube. Earth is Flat Bro. Name of the page. Can let 3 people up in the box. I got Google Meet if we need more. Google Meet's free. If you already have a Gmail account, then boom, just go to meet.google.com. I will set up right there. I got an email. username55@gmail.com. DJDarko55@gmail.com. Alright, since I ended McGlobeface and then all these fake flat earthers and they're tagging me
Oh, he mentioned me. He ended me. I don't remember that happening.
and trying to keep promoting semantics, let's start with Google. I will end you guys. Y'all all fake flat earthers who started out as a concave ran to Globey Live.
This is a 10-minute rant.
And made us viral by we flat smacked you successfully in 3 lives from 1 without having to leave the box. Now, you guys are claiming that flat has anything to do with the angle. It doesn't. I mean, it has anything to, it does.
Oh,
You're saying
see,
it has
he caught himself there. He caught himself
everything
there.
to do, I'm sorry, with the
He's so confused. He's confused himself.
texture of something. You know what I mean? Let's get into it. Like, come on, this is Oxford here. Horizontal. Oh, smooth. Well, let me tell you why that's bullshit. Let's get into it. And then, of course, the vertical, bumpy. We'll show you why that's a lie.
His finger.
But instead it's vertical. They put that in there, but that's not true. That's smooth. Let's get into it. Real quick. I cooked McGlobeface. They had no rebuttal to why the fuck it's only the hill. Anyway, let's get that out of the way.
Wait, hold on. He cooked me about what? So is it the hills and the valleys interrupting the flat? I have no idea what he's even talking about. Okay.
A slope. Alright, so a flat surface that is even and level with no incline, decline, or curvature. It's the opposite of vertical, which describes an upright position. Flat surfaces can be described as smooth. Can be. If their texture is uniform without bumps or irregularly. But you also got
Oh my God. I just want to see more pictures of him.
If it's non-flat, it would have the following characteristics. Slant, slope, incline, decline. Let's go further.
All right, so let's go.
Direction.
Oh, sorry.
And then you got a curved surface that bends continues like the dome, or non-rigid, flexible, irregular surface that might change like fabric or a trampoline, you know, like a blanket. Then we have smooth, refers to texture here. Free of bumps, roughness, or irregularities. Now again, Nikki was like, you have smooth ball. Of course, you have smooth ball and a smooth ball. You were trying to play semantics, act like a smooth ball is not the same as a smooth wall, a vertical plumb wall. So here's how you would describe a non-rigid surface that is slanted or vertically oriented. Again, you should use slanted, smooth surface, inclined, flexible surface, curved or smooth slope. Or just describe the specific traits like a smooth fabric draped in a diagonal slant. So therefore I asked it, then flat is not texture, it's directional, right? You're right. Flat is not necessarily the smoothest. Instead, flat is a geometric term that describes something parallel to the guide horizon. Forgive me. Or level. For example, a tabletop can be flat, but still rough. I don't believe that. So flat relates to well, I guess so, yeah. I don't know, but flat relates to orientation, horizontal, not texture, smoothness. Flat cannot be vertical. So flat cannot be vertical. If something is vertical, it's no longer parallel to the horizon. It is perpendicular to it. Flat and vertical are mutually exclusive. If you are describing something perfectly upright, plumb is indeed the correct word. Plumb refers to something being perfectly vertical, in line with, oh my God, that fucking bullshit word. Think of a plumb line used in construction. It is how you check true vertical alignment. A slope or a slant describes any surface that is neither horizontal, flat, nor vertical plumb. It is an angled surface that lies somewhere in between. Now you could have a rigid slope, right, that kind of does this, or it's kind of bumpy, or I would say that stairs are a decline in an incline.
Anyway, woo! Icy spin for $2. When I want to know X, I ask about X to learn. Yeah. Well, I often wonder why they don't just Google the answer they want from ChatGPT. I guess that would be too easy. So I asked this guy, I meant to go look for it, if he wanted to send me a picture or anything, and he goes, "No, just pull it up from my alt account." So yeah, so this is the picture that's going to be on my debate thumbnail. It's exclamation X. I don't get it. I might be theoretically displaced. Oh, when you want to know about X, you ask about something else. Yeah. Is that what you're getting with that? I see spin. Yeah. It's pretty much not X. That's where you're going with that. Not X. Yeah, I get it. You want to learn something, you ask something else and get your answer. Why not just ask if flat is vertical? If something flat can be vertical, why not just ask that? If that's what you're looking for, just ask it. And you'll see yes. My wall is flat. Because flat is referring to the surface of the wall, not the orientation. Now, if you change the word, if you change the sentence, it could mean that. If you said something like, I took the TV off the wall and I laid it down on the ground flat. Now, the meaning has changed because you're saying you laid it down flat. So we know you mean you laid it down horizontally. But you could say my flat screen TV is laying flat on the floor. Now we have two different meanings of the word flat in the same sentence. Wow. My mama taught me that. It's a game of beat around the bush. Yep. Fred's like this. You'll see in my video I'm putting together of Fred for the top left. But he's way more entertaining. He's just more exciting when he yells. So he went on with Dr. Blitz today on TikTok. I don't know if any of you guys know Dr. Blitz. He's a PhD in physics, mathematical physics. So he hopped into PhD Blitz's live for some reason. I don't know what he was thinking, but it was an absolute shit show. He was just yelling. At the end, he was just being homophobic. He was just insulting Blitz's looks the whole time. It was great. He refused to answer any questions. But he won't come debate me. He won't leave his TikTok lives. He said he refuses. But then he goes and shows up in Blitz's live, so I don't get it. Blitz is way smarter than me. Yeah, so you can all look forward to this or not. I think it's going to be fun. But yeah. Let's wrap that up here. I'll hop over to Mctoons chat and see what's going on over there and mess around in the chat for a bit, refresh my drink. Thanks for coming on. Hopefully these lives are getting a little smoother as far as the technical stuff goes. I'm starting to figure it out. It is annoying. It is. That's one thing I do like about TikTok, and I think I figured out why the flirfs stay there. They love it there because it's easy. It's very easy. You want to go live, you press the live button, live, and you're just live. And you're like, oh my God, I'm live. What am I doing here? I don't know. I press a button, I got a green screen effect. I got, all sorts of effects you can put on, and then you can just let everybody up. And then, you want to come in? Come on in. It's very easy. This is difficult. It takes effort. It takes work. And I'm not willing to put that effort in. Do I make a living on TikTok? I do not make a living on TikTok. I don't make anything on TikTok. TikTok is a waste of space. I have 55,000 followers on TikTok, and they don't show my videos to anyone. My last 4 videos got just several hundred views. They used to get 10,000 views. Sometimes a good one would get, a couple 100,000 views. But yeah, they just, I think I'm in the penalty box, and I've been there for a few years now, and I'm never getting out. I'm just been reported too much. My main account was permanently live banned 2 years ago for playing KK Caleb, his words when he was talking about Hitler and how he was defending Hitler. So I was playing that on my live, and we were talking about how disgusting it was, and I got live banned permanently for doing that. Meanwhile, his video is still up. Figure that out. And his account and his lives. My day job, I work for an engineering firm, defense contractor. Fairly large one, top 6. I'm in management. I'm a manager over there now, one of the groups. So yeah, I do that during the day. Fun times. And then I do this at night. Flirts don't get reported. I mean, they do, but it's weird. TikTok is just so inconsistent. They're so inconsistent that somebody can make a video about me and call me a piece of garbage and threaten to kill someone or threaten to do something. And I could replay that video and be like, look what this guy said about me. Look at it. Expose it to the world. Here it is. Look at this piece of shit. And I'll get the video taken down. But his video won't get taken down, even if you report it. They're very inconsistent. We were all live the other day watching an extremist live where several of the people on the live just had swastikas up as their various types of backgrounds, talking about this stuff. And we were streaming it. We were in a live, and then someone on the live had their phone pointed at the other live. So we were watching their live through our live. And we were just discussing it gingerly, and a bunch of us got live banned. I got a 3-day suspension. That live never got taken down for hours. Hours it was up. Right, so it's that kind of shit. But now I'm rambling. But yeah, the short answer is no, I don't make a living on TikTok. You need millions of followers on TikTok to make a living. I think my last check I got from TikTok was $1.65 for last month. So no, they're not, especially with this kind of programming. There's nothing you can do over there. You need to be a crazy conspiracy theorist like Fit Flat Earther. He's making a living, or at least a second income for sure. He's got 500,000 followers now, and he just spouts conspiracy nonsense all day long. Here's Joe Biden. Oh, what was his last one? It was 2 actresses. I forget. He was saying his new thing is everyone's a clone, right? Everyone's a clone. Everyone in Hollywood's clones. And then he'll find 2 pictures of someone and they'll have a similar mole, and he'll be like, "Told you so. Look at these moles. They match." Pfft, clones. And hundreds of thousands of views every time. Like, you could go, any one of you could start a TikTok account right now, go over there and just start putting up videos where like you film the sun and the moon in the sky at the same time and be like, this isn't the same sun I remember as a kid. It's hotter. It's hotter. I don't know what's going on. And what's the moon doing up with the sun at the same time? I've never seen that before in my life. That's it. That's the whole video. That, and it'll take off. It's such a cesspool of shit. And of course, as soon as I quote unquote leave TikTok, you know, we got Space Audits and Shane and that group of people going over there now. You know, one of the reasons I was not sad to leave is because it was the same 6 flat earthers I talk to every day. And how many times can you hop on a live and explain to them the same thing you explained to them yesterday, or listen to a live where they're just repeating themselves over and over and over again? Water finds its level, does it? Most flat earthers don't have jobs, or at least a lot of them don't. They're on TikTok all day long, the same ones, all day long. Maybe they're working from home doing something, but I don't think a lot of them have jobs. I think Witsit was making a full income. I don't know. It's hard to know the dollar value. I'd have to really go look at all his subs and stuff, but he was making enough to make it a living, for sure. He doesn't have another job. Jaron doesn't have another job, right? These are their full-time jobs. David Weiss doesn't have a job. This is his full-time job. So he's making enough to do something. All right, guys. Anyway, thanks for coming again. I said that like 45 minutes ago, and then I went off on a rant. I'm going to peace out. Appreciate everything. Appreciate the likes. The memberships, again. Feel free to join up if you like. Always helps. And, wrong time to mention it, but there is a store. If you go to my my YouTube, there's a store channel. I'm going to start putting up some stuff. My first line of things is just dumb shit flat earthers say. And we have, see if I can show it. I want to do I'm going to do a deck of cards with their pictures and just dumb quotes. I think that would be fun. I'm pretty sure I'm just making things for myself, because I'm just going to buy everything and then probably not expect anybody else to buy it, but at least I'll have a couple of things for myself. Let's see. So if you have any ideas, you can shoot them off to me in my Discord. There's actually a slot for ideas of stupid quotes flat earthers have said. Where's this thing? So we just got like a David Weiss one. The first one you probably won't get. It's a TikTok reference, inside joke for. How do you see this shit? I mean, that's annoying. Well, it's not showing me it on the shirt, but you can see it here. That's just the picture it's going in the background. So we're going to do a line of stuff. I don't know why it's not showing me the shirt. So we're going to do some products with that on it. And then here's a good look at it. Of course, it doesn't make it bigger when I do that. Why is it not? Weird website. I can't click on the damn picture. But anyway. This one was funny. I made a video about it on TikTok today. Rise it in the morning. Let's see if this is it. So there was he was on the live today. If you notice, he jumped in. If you go rewatch it, his name is T.E. Flatsmack. He joined. He's tried to say a few things, but nobody paid any attention to him, and he probably left or he was muted. We go back a few years, but he tried. Do I have it on here? He tried to claim that the Earth had two suns because here it is. I do have it on here. So he gave me this picture. He put this picture up, and he goes, we were talking about sun angles and stuff and how the sun could be behind you to the south of you in Chile or Antarctica or whatever when the sun's to the north of you on flat Earth. And he goes, I don't know, it could be portals. There are two suns. He pulls up this thing. He goes, there's two suns. This picture right here, thanks, Zane. Zazin 69? Am I saying that right? So we're going to do fun stuff. I got to find my baby keys. I lost them. They're my favorite. I shake them at flat earthers when they're not paying attention during debates. I'm going to need it on Monday, I'm sure. Anyway, this picture right here. Oh, you're not seeing that. This picture right here is an animation of Rayleigh, a planet from Star Trek, from DeviantArt. So he put this up as proof there's two suns. I just reverse image searched it and came right up. The joke was, though, that as I was searching for it, there's a website that came up and they sell coffee with that picture on it. And that picture is the picture of Rayleigh with the two suns. So the joke going around a few years ago was the best part of waking up is Rayleigh in your cup. And we just would lambast him with it every time we saw him. So now we have a coffee mug that I'm in the way of. Best part of waking up is Rayleigh in your cup. And on the back is Jean-Luc Picard with his head in his hand. So inside joke for the TikTok crew, but that one makes me happy. Definitely going to be my primary mug when it shows up. Wondering why I can't. Oh, maybe if I click here. See if that takes me there. It's just copying it. Oh, there we go. I get a little bigger anyway. And then here's the cup with Jean-Luc in the back. So yeah, anyway. Appreciate the time and effort for the fourth time. I'm actually going this time. So I'll peace out. I'll see you later. I'll see you all Monday if you join me. All right. I'm going to send out a reminder video to follow that for 9 p.m. on Monday. All right. Thanks, guys. See ya.
Sailing off the world's edge in the breeze. No gravity, no satellite seas. Just believe in your fantasy. Yelling about conspiracies in the night, while we orbit the truth in plain sight. So stubborn, so wrong, it's quite a plight. You believe you can shine the light.